Hello students, welcome back to OrganiChemVerse YouTube channel. In this video, I am going to solve these two questions from Hydrocarbons chapter. I have taken these questions from Balaji publication book for NEET students. Let's begin with the first question. How many distinct monochlorinated products, including stereoisomers, can result when the alkane below is heated in presence of chlorine? By now, you know what is monochlorination. A monochlorination reaction is when a hydrogen is replaced by halogen. Now the question is how many stereoisomers will be formed along with the other products in the given reaction. Whenever you have a molecule like this, first you need to understand what are the different types of hydrogen we have, how many types of hydrogen we have. This is a methyl, so these are primary hydrogen. There is one hydrogen here which is a tertiary, right? We have two hydrogens here. These two hydrogens are symmetrical to these two hydrogen. What are symmetrical hydrogen? When you replace either this hydrogen or this hydrogen by a chlorine, you are going to end up with the same product. That is called as the symmetrical hydrogen. And we have two more hydrogen here. Only these two are symmetrical and we have hydrogen here. Okay, so these are secondary hydrogen. Now let's start chlorinating the given molecule, then we can think about the stereoisomers. First we will remove hydrogen from the methyl group. So this is one product. So we are supposed to get monochloro. There is only one, right? So now let's take this methyl. I'm going to replace this hydrogen by chlorine. So directly I will write like this, okay? Same way, let me remove from this carbon. So what I'm going to get, the methyl is as it is, okay? So the chlorine. So whether I remove from here or here, it's going to be the same product. That's why, okay? So now let's take up here. We have methyl, and where the hydrogen will be replaced now? Here. Okay, so we have 1, 2, 3 and here, so 1, 2, 3, 4, 4 different. So that's why we got 4 products. Okay, as of now I think it's clear to you. Okay, now let's get back to stereoisomers. First you need to understand what are stereoisomers. Stereoisomers have the same molecular formula, the bond connectivity is also same, but the spatial arrangement is different. What does that mean? The group arrangement in the space, above the plane, below the plane, same side of the plane. So this is called as stereo. So such molecules are called as stereoisomers. There are two types of stereoisomers you have learned, that is, what are those? Yeah, geometrical and optical. When geometrical will be there? When we have molecules like these. That means what? There is a plane. There can be two groups on the same side of the plane or opposite side of the plane. Same with this also. Like this, right? So such molecules exhibit geometrical isomer. To be precise, what do you call it as? Yes, that is called as cis and trans isomerism. Now, for optical isomers, we need to have a chiral carbon. What is chiral carbon? A carbon attached to 4 different groups. We call that it is exhibiting chirality. So that means what? This molecule, this kind of molecule can rotate the plane of a plane polarized light, nothing but optically active. Do we have any carbon which is attached to 4 different groups? We need to check that. Look at this. Okay, this carbon is attached to methyl, hydrogen, right? And a carbon attached to hydrogen and chlorine, a carbon attached to 2 hydrogen. That means what? Yes, it does have a chiral carbon in it. Okay, what about this? So CH2, CH2, same group, so you can't take this as chiral. Same with this also, you can't take this as chiral. So it is exhibiting both optical and geometrical. So now things are getting a little bit complicated because you don't know how to count such molecules. Don't make it complicated. I'll give you a simple trick, okay? In that case, what you do, 1 and 2, you already have two molecules. Write that as it is, okay? We'll do a simple math now, okay? Now, what about this molecule? First, we'll identify what sort of isomers it is exhibiting. Whenever we have this molecule, it can exhibit cis sign trans. What does that mean? Observe here, if this is cyclobutane, the methyl groups can be on the methyl and chlorine can be on the same side, or it can be on the opposite side. I have written cis, but other way around, you write chlorine here, H here, then it will become trans. That means what? It is exhibiting 2 cis sign trans. Therefore, I am going to write 2 here. Okay, now let's analyze this molecule. This molecule also exhibits cis sign trans. Therefore, how many I got now? 2. And what about this? Whenever you have optical activity, you don't use cis sign trans, you use the configuration called as R and S configuration. R and S configuration. That means it also exhibit R and S. Therefore, you can write 2. Now you can count the number of molecules. How many do we have? 2, 4, 6, 8. So all put together we have 8 isomers. And where do we have that as? Option D. Or simply, if you want to save the time, see, you already got 4 structures and there is a cis sign trans, so obviously it will be more than 4, right? And then there is a R and S, obviously it will be more than 5. So there is only one such option with more than 5, and that is option D. So go ahead with D. By that way you will be saving lots of time, okay? As you keep on solving these kind of examples, you will understand how to eliminate the other options. Definitely it is not option A and B, right? Because the number of optical isomers are given, optical isomers are total, altogether isomers are given very less there, right? So in that case it has to be either C or D, right? So when you know that it exhibits geometrical as well as optical, definitely it will be more than 5. Therefore, you can go ahead with 8. Now, let's take the next question. This is a very simple reaction. We have a cyclohexane. It is reacting with bromine in presence of sunlight, followed by sodium in dry ether. What is product B? Very simple. You need to know what are these reactions. The first step is bromination of cyclohexane, and it will give you bromocyclohexane. You don't have to write mechanism and stuff here, okay? How quickly you are going to get the answer, that is what is important. Now, whenever there is a sodium dry ether, remember it is always a named reaction called as Wurtz reaction. Wurtz reaction is a method used to prepare alkane from alloalkane. So this undergo reaction with itself in sodium and it will form dimerized product. So the bond will break here, the same molecule reacts, right, with each other, and it's going to form a bicyclohexane or dicyclohexane. Both are correct. And where is it? It's given in option A. Therefore the right option is A. I hope I made it clear. Thank you for watching this video.